Welcome to another bite-sized episode of Cream Rises Up. Fusion has been considered as the holy grail of renewable source of energy for decades, but plenty are the difficulties surrounding the technologies that it has thus far remained an enigma. Pound for pound, fusion makes 4 million times more energy than coal and creates none of the emissions or problematic waste of current energy generation methods. However, it is exceptionally difficult to create the conditions needed to initiate fusion, and harder still to sustain it for long enough to produce more energy than it requires. Currently, there is a huge craving amongst politicians and policymakers in the Western world to have an energy source which is both powerful enough and clean at the same time. Following this theme, UK officials are building on 4 decades of research and are in the early stages of turning a former coal power station in the East Midlands into the world's first fusion power station. The project, called Spherical Tokamak for Energy Production, or STEP in short, is expected to generate energy from fusion reaction by 2040. Paul Methven, the director of STEP, admitted the technology is in its early stages and refused to guarantee the project would materialize by 2040. Mr. Methven doesn't want to divulge how much the project would likely cost. The project is already absorbed £200 million of British taxpayer money, and it will likely cost more before it reaches completion. A revised timeline and cost analysis will be released by 2024. UK scientists were reviewing 66 design concepts and 150 different drawings in a bid to crack the code for creating a successful fusion reactor. For now, engineers will use 22-meter-tall spherical tokamak to merge 2 forms of hydrogen, deuterium and tritium, to make helium and therefore release huge amounts of energy for use. The globular, sun-like plasma formation will reach a whopping temperature of 100 million degrees Celsius and will measure up to 3.6 meters of radius. To control this miniature sun, magnets will be used. In order to make the tritium fuel, which is one of the main ingredients needed for fusion reaction, engineers will deliberately infuse neutrons spewed out by the helium production process to produce the tritium fuel. Producing enough tritium is crucial for the success of fusion energy because it is one of the rarest hydrogen-based isotopes found on Earth. On the other hand, deuterium, which is another hydrogen-based isotope and needed to create a fusion reaction, is not as rare as tritium. Engineers are hopeful that the British-based fusion reactor will generate up to 1.6 gigawatt of power, about half as much as Hinkley's Point C nuclear station, which equates to a net output of up to 200 megawatt electric energy. The initial blueprints are likely to change significantly over the coming years as the concept gets revisions and refinements. According to some experts, construction at the West Burton is expected to start in spring 2024, and future optimizations and material breakthroughs are expected to increase efficiency and boost output. Mr. Methven couldn't hide his excitement when he said, quote, "STEP is Fusion's Apollo. It is an incredibly exciting opportunity for the UK to be at the forefront of this new frontier." The director, however, is not promising with full certainty that we will see fusion-powered homes in the coming 2 decades. Supporting this view, he said, quote, "I think it would be hubristic to give cast iron guarantees about the lights in this room being powered by fusion from that plant within a particular timescale. Scientists working on STEP are harnessing the power of supercomputers and created digital twins to troubleshoot any issues arising while they are constructing this monumental fusion reactor. This allowed them to skip physical testing, which is expensive and time-consuming.